Hey guys, so today we are going to discuss the last topic of energy conservation of thermodynamics and systems. So, in this topic, we are going to discuss the heat pump and its application. So, before discussing that, we need to know what is a heat pump. So, heat pump is a device from which, so let me draw a diagram. So suppose this is a high temperature and this is a low temperature and this is a heat pump. So heat pump is a device which pumps heat from low temperature source to a high temperature sink simultaneously with the help of an external source of energy. With the help of external source of energy. Now now you may be thinking that what is the difference between refrigeration and heat pump? So refrigeration also does the same thing. So it takes heat from low temperature and it gives heat to the high temperature. The difference between refrigeration and heat pump is that the the area of interest. So our area of interest is the high temperature source, while in the refrigeration our area of interest is the low temperature zone. So heat pumps are designed to move thermal energy opposite to the direction of spontaneous heat flow by absorbing heat from cold space and releasing it to warmer one. So heat pumps are efficient for heating and cooling systems and they can significantly reduce the net energy cost. So heat pumps also works extremely efficiently because they simply transfer heat rather than burn fuel to create it and also help in the reduction of greenhouse emission in various industry applications. So the most common examples of the heat pumps are air conditioners and freezers. So heat pumps are a volatile evaporating and condensing fluid known as refrigerant. So in refrigeration also we do the same thing. So refrigerant is responsible for transferring and transporting the heat. So refrigerant has a low boiling points. So low boiling points, then all liquids so that only heat source needed is the room temperature fluid. The boiling point can be altered by changing the pressure. So this can be altered by changing the pressure. Now let's do the working of a heat pump. So initially the refrigerant is a cold and is at a low temperature. So let me draw. So there are four components of the refrigeration. So first is compressor, then is an expansion valve. So after compression, there comes a condenser. This is a condenser, and here there is an evaporator. So evaporator. So it goes from here to here to here to here to here. So in evaporator the heat is been taken and in condenser the heat is been rejected. So let's start with an initially the refrigerant is cold and is in low temperature and the liquid gaseous state flowing through the tubes. So actual heat get from the environment or the room. So it happens in the uh, evaporator. So temperature liquid takes place in the evaporator. So here the refrigerant is converted from liquid to gas. So this is where the liquid refrigerant comes into play and which boils and evaporates even in sub-zero temperatures. So low pressure vapors are formed by absorbing heat from the air or liquid at a room temperature as liquid refrigerant changes to gas. So once it passes through the evaporator, the refrigerant is warm gas since the refrigerant is not that hot to warm the target liquid, so the compressor comes into the picture. So the compressor raises the temperature and pressure of the refrigerant. So this will raise the temperature and pressure of the refrigerant, because the volume reduction and the forces of high temperature high pressure gas to other heat exchanger called condenser. So here the temperature is being reduced in the condenser. So condenser takes heat from the high temperature gas and passes it to the target liquid. By cooling process, the refrigerant again comes to the liquid form, which turns, so this, from gas to liquid. So which uh, liquid form, which transfers a lot of heat to the liquid, and after expansion valve, so it causes reduction in temperature and pressure, and engineers cycle once again. So after converting the liquid, it passes through expansion valve, and again the cycle repeats. So this is the working of a heat pump. So applications of heat pumps are generally in dairy industries, pharmaceuticals, textiles, food processing, cold storage, automobile, and cold utility are like air conditions, process coolings, potable water drinking, and hot utilities are also boiler feed water preheating, drying, and etc. So this is the working and applications. Now I'll see few cold storage applications. So what are the cold storage applications? So cold storage applications. So cold storage is a method of preserving perishable commodities including dairy products in their fresh and wholesome states for extended periods by providing and controlling proper temperature and humidity conditions within the storage compartments. So because normal atmospheric conditions of temperature and humidity are seldom at a level conducive to the safe and prolonged storage of perishable foods, it is necessary that artificial methods to be provided to produce such an environment. So, uh, perishable foods means foods which get uh, which the foods which generally get uh, the foods which get spoiled easily under normal temperatures or general temperature, so it has to be kept in lower temperatures. So it is necessary to that the artificial methods to be provided to produce such an environment. So cold storage plant also works on the vapor compression refrigeration cycle. It is VCR. It is VCR cycle. So this safe environment is formed of various favorable conditions of air inside the cold storage. So what is the environment that is formed? So we'll see one by one. So first is temperature. So the first condition of an air required in a cold storage is low temperature. So low temperature retards or arrests most of the spoiling activities like bacterial growth in dairy products. The second is humidity. So it is the moisture content of air in cold room. It is also an important parameter and required to be kept in a certain range. Very low humidity means the product will lose its moisture due to the increased evaporation and dry air. Very high humidity means the growth of the bacteria will take place. So how the effect of humidity is lowered down either by packaging the products or by wrapping this with the moisture resistant papers. So this can be avoided by packing it. Then third is motion of the air. Motion of the, let me write, motion of the air. So It means that the cold air should not be stationary but should flow continuously over the products for better heat transfer. So it is ensured that suitably designing the cooling coil and blower. So air should be moving. Then fourth is purity of air. Purity of the air. So it is also important parameter because impure air may badly affect the quality of food products stored in. Suitable measures are taken to ensure purity of inside air. So these are the various factors which need to be taken care in a cold storage. Now, so prior considerations in deciding inside conditions of a cold storage. So what conditions we need to design before putting the foods. So in actual cold storage, uh, conditions are determined by first by the type of food. So type of food, sorry, this type of food, your food to be stored, and second by the length of time such foods are to be stored. There is type of food and length of time that food to be stored. So first let's discuss the type of food. So in type of food, so foods in which the living process continues, that is, this absorb oxygen and produce respiration heat. So fruits and vegetables comes in these categories. So fruits and vegetables comes in these categories. So the low temperature exposure has only a retarding effect on these foods. So non-living foods, so now the non-living foods such as meat, fish, and dairy products that are highly susceptible to spoilage agents. These products deteriorate rapidly unless the drastic preventive measures of preserving this are taken. So that is that is for the non-living foods. That is non-living foods need to be prevented much earlier. This is type of food. Now let's come to the second point, that is length of time, or let's call it storage time. So this is the second consideration, it is length of the time for which the dairy products are required to be stored or preserved. So it decides chiefly that the products are to be stored in a frozen or unfrozen state. So the storage period is less for unfrozen products and longer for the frozen products. So it's obvious that the period is less for unfrozen products and more for frozen products. So, however, this rule is not so simple because the storage period, even in frozen states, varies considerably from product to product. So, freezing temperature also varies for different dairy products. So, this is the length of the time. Then the third, the most important, is temperature. So, type of food, then length of time and temperature. So some dairy products like ice cream is always stored in frozen conditions, that is a deep low temperature. So depending upon the available data, the mean parameter, is temperature to be maintained in cold storage, as decided on the basis of dairy products and duration of storage. So depending on the temperature range, the principal refrigeration system employed with cold storage is divided in two groups, such as chillers and freezers. There's chillers and freezers. So chillers maintain a temperature above 0 degrees Celsius, that is above the freezing points of products, and freezers maintain temperature below uh, 0 degrees Celsius, this is below the freezing point of the products. So these are the main difference between chillers and freezers. So this were the main topic, that is this was the main consideration in deciding the conditions of cold storage. So this ends the chapter, the biggest chapter of this subject, and we have discussed each and every topic. So that is this ends the chapter. So that is energy efficiency, efficiency energy efficiency in thermal utilities and systems, in thermal utilities and system. So this ends the energy efficiency thermal utilities and system. So in this, as we know, we have discussed first the boilers, so how we can save energy in boilers and etc. Then we have seen steam system, so how we can save energy in steam system, and what are dry layup and wet layup, how when boilers are not in use, then how we can close it or switch it off. Then the third is furnaces. So furnaces are the places where the main goal is to melt any metal, or to create a very high temperature zone where the metal is being melted. So there is the furnaces. Then the fourth we have seen is insulation and refractories. So the main goal of insulation was to provide a heat, uh, to provide a stoppage of wasting heat to the environment by providing the insulation. So in that also we have seen that economic thickness of insulation, that is ETI, that above which if we are insulating, then there is no sense of insulation. And also refractories. So we have seen that how we can save energy in this. Then we have seen the fifth is heat exchangers. So in heat exchange also we have seen pinch analysis and how we can save energy in that. And we have seen also various types of heat exchanger, shell and tube type heat exchanger, etc. Then waste heat recovery. So how we can recover waste heat, and what are the various devices, that is economizer, air preheater, then recuperator, regenerator, and etc. etc. Then we have seen the cogeneration. So cogeneration, in that we have seen topping cycle and bottoming cycle. In this also we have seen that this was the combination where the electricity and heat both are required in any company. Then it can be installed, that where the heat requirement is greater than the electricity requirement, so that it can be used directly in the form. So that is cogeneration. So this bottoming cycle and topping cycle, that first electricity generated and then heat is generated, and other that heat is generated first and then electricity is generated. Then we have seen the HVAC and refrigeration system. So heating, ventilation, air conditioning, refrigeration system. So what are the various that is VAR and VCR cycles, and how it is depending, how we can save the energy in that. And at the last we have seen the heat pump and its applications. So how heat pumps are used, and what is working, and uh, where the cold storage are there and what are its applications, and etc. So this is the main topics which we will discuss in this chapter, and this ends this chapter, and this is a very big portion in this subject, so it has higher weightage than other chapters, but it's much lengthier. So I hope you understood, and we'll start a new chapter from the next lecture. So thank you very much. Hope to see you in the next lecture.